All right, I did lengthen this assignment a little just to give you enough of them to practice. So now you just have 4 of these problems to do. I know they have a lot of parts, but they're actually pretty repetitive, so I don't think it's going to be too bad. All right, so in part A, it asks for the domain. That's the x's, remember, and that's the width of the picture. And then it asks for range, and that's the height of the picture. So if I look at this example over here, we're looking at this line, and if we just think about the width, because it keeps going forever, then it really doesn't have a width except to say from infinity to infinity. So for that example picture, it goes from negative infinity to infinity. That's its width. Now its height, on the other hand, it has a bottom, and they're going to label that for you. In this picture, this is as low as it can go. Now it keeps pointing up forever, and it's really hard to imagine, I think, the left and right sometimes, because it looks like it keeps going up. But if it kept going on forever, it would eventually keep going off to the left too. Very slowly, but it would. And same here with the right. If we keep pointing this way, it is also getting farther and farther to the right. Super slow, but it is. But because of this bottom right here, it does have a bottom, and the lowest it goes, so -1 is its x coordinate and 2 is its y coordinate. So the lowest it goes is 2. I know it's hard to tell from my ugly picture, and then it can keep going up forever. So its height is from 2 to infinity. We really frequently see negative infinity to positive infinity. We don't have very many of them where they actually have a limit either way. But what you're looking for is a clear bottom or a clear top, which might look like something like that, and then nothing above it, or a clear left or a clear right. So you're really looking for that U shape with nothing else on the other side. That would tell us that there is a bound. All right, then they ask for the intercepts. That's just where it crosses the axis. All right, this one will never cross the x-axis because this is the bottom and it doesn't go any lower. And it will never cross the y-axis because see this dotted line? That dotted line is called an asymptote. And an asymptote shows us where the function cannot go. So it will never cross that line, just like an invisible fence for your dog. This thing doesn't cross it. Why does it not cross it? Because what that usually means is that this function had some reason that it can't go to that. So for example, if we have an x on the bottom, that means x can never equal 0. And because x can never equal 0, there's an asymptote there because it can't go to that number. Now there's different ways that can happen, maybe because of a square root, and that means we can't plug in a negative. But from the picture, all we need to know is that these dotted lines are somewhere it cannot go. So this function cannot go and touch the y-axis. So its intercepts, it doesn't have any. It will never cross either of the axes. Now we talk about asymptotes, and remember that's just the dotted lines that are on the paper, and there's 3 kinds. Horizontal, remember that means straight across, that way. Vertical, that's up and down. And oblique is the fancy mathematical word for sideways. So we're just looking for all the asymptotes, and we write them down. Horizontal ones always go y equals a number. That's it. And vertical ones always go x equals a number. That's a dash, not a negative. That's really confusing, sorry. And oblique ones are just going to get written in that usual slope-intercept form. So if we look at this one, I see one vertical asymptote where that dotted line is. And because it's right on the 0, that vertical asymptote is going to be x equals 0 for this picture. There's also an oblique asymptote, and it's going to get written in slope-intercept form. So I'm going to write y equals, and then I have to figure out the slope. This one goes up 1 over 1. They're usually going to make it real obvious. So our slope is 1, and our intercept for that oblique asymptote, the asymptote crosses at 0. So the dotted lines are not part of the function. They're a little line. It's not allowed to cross, like an invisible fence, kind of like that little yellow line they put on the football field during games that shows what they're trying to get to, but it's not really there. It's just like to show you where the first down would be. It's kind of like that. It's not really there. That's why it's dotted. It's not part of the function. It's showing you where the function is not allowed to go. Okay, so let's do it one more time. This one is a little more complicated. It's domain. That's how wide the function is. Because of these arrows here, it's going to keep going left and right forever. So its domain, woo, that's sloppy, sorry. My paper is always trying to slide, is negative infinity to positive infinity. That's, sorry, doing my best. All right, its range is how tall it is because it points down forever, because it can go up forever. That's also infinity to infinity. If you ever have to guess, a good guess is just infinity to negative infinity to positive infinity, all the numbers, because that's what usually happens. Okay, then it's going to ask us in part B for intercepts. Any place that it crosses the axis, whether that's the x-axis or the y-axis. Well, this one crosses at, let's see, right here. So at negative 2, 0, it crosses. And I did a really bad job of copying this picture out of the book, so I put it crosses at negative 2, 0. They actually had an asymptote coming out of the x-axis too, which means that this will never cross. It will get close, but it will never cross because it can't cross that asymptote. So there's its only intercept. The only place where it crosses one of the axes is right there where we can see it. Okay, and then for C, it's just the beginning of when it's asking us about asymptotes. So part C is horizontal asymptotes. Remember, horizontal straight across. So yeah, it has one at y equals 0 because it's 0 high. Okay, and then part D is asking us for those vertical asymptotes. Are there any that go straight up and down? Yes. Here's one right here at x equals 1 to x equals negative 2, and another one at x equals positive 2. So it has two of those. X equals 2, x equals negative 2. Does it have any oblique asymptotes? Remember, those are the slanted ones. I see no slanted dotted lines, so there aren't any, which is fine. A lot of these have none on a lot of these pictures. So that's all there is to this section, and you have 4 of them to do. I'm so sorry, my paper keeps moving while I try to write. So you just look at each of these pictures. You answer, how wide is it? Okay, this one, see how it's pointing, an arrow pointing left? So it's from negative infinity all the way to positive infinity. How tall is it? This one is pointing down, so from negative infinity all the way to positive infinity. And then it asks about where it crosses the axis. You are going to be able to see it right there. See, there's the point it crosses. That's the only place it crosses, so that's the only point you need to name, 0, 0. Horizontal asymptotes are the ones that go straight across. This one has one at y equals 1 because it's 1 high. Vertical asymptotes, yes, there's one right here at x equals 2. No oblique asymptotes, those are the slanted ones. So in your book, it's even easier because they make those dotted lines red, so they really stand out. But just watch out, check your axes. There is an asymptote right here because you can see that little red dotted line. So that's how they mark that there is an axis and an asymptote right there. So make sure you don't miss those when they do it. Like there's one right there that's kind of coming out of the axis, so that's also an asymptote. So for all the asymptotes, you're just naming which ones are the horizontal ones, which ones are the vertical ones, which ones are the oblique ones. That's it, and then you're going to do those 4 and turn that into me. All right, hope to see you tomorrow.